Can you guys see what's happening here? Maths. Hello guys. This is me going live on my YouTube channel. Welcome to my YouTube channel. Hi sir. Ayabulela Jarder. Who's Ayabulela Jarder? What grade are you in, Ayabulela Jarder? What grade are you in, Ayabulela Jarder? Hello, Rialebucha Motiba. Hello guys, what grade? What grade? Ayabulela, what grade? Rialebucha Motiba, what grade? Menier Dinchangmo. What? You guys are speaking in tongues. Me, I can't relate. What grade, guys? What grade are we in? Dinchangmo. What? I need my translator. Grade 12. Grade 12. All right, guys. Are you back at school, guys, with grade 12 and stuff? Yeah, because I was thinking here, I wanna do sequence in series. Right, I saying Tapelo in TikTok. Things are not going so great in TikTok. I don't know, my TikTok is crashing, guys. It's crashing bad. I don't know why. I don't know what's happening with my TikTok. It's crashing so bad, it's not even funny. So that's why I've actually relocated. I relocated here to see how is it YouTubing. All right. Okay, it seems like we have grade 12 and grade 11 only here, as I can. Sorry, grade 12 and grade 10. Hey, but what about my moderator position? It can be. No, guys, hey. No moderator positions here. No positions. Yeah, it's insane. All right, guys. Grade 12, since I think in the majority we have grade 12 people. Am I correct? In the majority, I see there's 15 people that I can see that are visibly here in the live. But I just wanted to see if are you guys fine with me starting sequence and series like from the beginning, as if I was teaching sequence and series, officially, or would we rather I not do that? What do you guys think? I mean, I'm not ready for grade 10 pure maths. You must do trig. Suka. I'm not ready for grade 10 pure maths. What is that? Not ready for grade 10 pure maths. Hi guys. How can you not be ready for grade 10 pure maths? By the way, trigonometry for grade 10 is quite simple and nice and pure and good. It's very pure. There's no pure mathematics and trigonometry. All right. My grade 12s, would you be fine with just me introducing a little bit? Hey, I'm the silliest mouse. I have come to officially rate live YouTube shorts from 1 to 10. This video gets a 6 out of 10. Go on. I'm the silliest mouse. What is this? Rialibucha, the yes sir. What is the yes sir for? I'm in grade 7. Can you teach me something that I can be ahead? Grade 10, grade 7. Remember my grade 7 kids, I'm not really teaching grade 7. I teach grade 8, 9, 10, 11, and 12. All right. So Rialebucha Motiba, when you said yes, sir, was it yes, sir, that is it okay that I go ahead and teach something in grade 10, pure maths, or would you rather me start grade 12 maths as if I was teaching a class from the beginning, at the beginning of a term? Because I can do that. I don't know what you guys think. And it just means every single live stream, I'm just gonna take it one step, one bit at a time. Yeah. Anyways, I think to be honest, my evening times are dedicated to grade 12 anyways. So let's push grade 12. So let's start grade 12 then. Okay. All right. Okay, guys, so let us be starting. In a typical grade 12 class in the beginning of the year, grade 12's maths will come, and the first thing that will be touched on in that particular class is that you will revise quadratic number pattern. Right? You will revise quadratic number patterns. So to begin, guys, let's just refresh. In a quadratic number pattern, okay, we must remember the general term is this one. Tn is equal to an squared plus bn plus c. We remember that, right? Then if we check out what term 1 is, we substitute in the place of n1. That means a into 1 squared plus b into 1 plus c. So that means we have a plus b plus c, which is term 1. Okay. What about term 2? Means in the same position of n, we're going to substitute 2. So that means a into 2 squared plus b2 plus c. So that basically means we are going to have 2 squared is 4, so that's 4a plus 2b plus c. That's term 2. And I mean, we could go on. What about term 3? So we do the same thing. We substitute in the place of n. We have a into 3 squared plus b times 3 into c. 3 squared is 9, so we have 9a. B times 3 is 3b plus c. So this is our terms. A plus b plus c, which is term 1. Term 2, which is 4a plus 2b plus c. And then term 3, which is 9a plus 3b plus c. Term 1, term 2, term 3. Then if we check the first difference, in other words, we take term 2, we subtract term 1. 4a minus a is 3a. 2b minus b is b. C minus c is 0. So we have 3a plus b, which is our first term in the first difference row. If we do the same thing here, 9a minus 4a, that gives us 5a. 3b minus 2b, that gives us b, right? And then if we look at our second difference, 5a minus 3a gives us 2a, right? And b minus b is 0. So this is our original sequence. This is our first difference row. And then this is our second difference. Okay. So I'm sure you are familiar with these three expressions: 2a, 3a plus b, and a plus b plus c. So whenever we want to find Tn, to get a, we always take the expression here and we equate it with the second constant difference. Whenever we want to find this b, which is the b that is the coefficient of n, we take 3a plus b and we equate it with the first term of the first difference. First term of the first difference. Then lastly, a plus b plus c. Whenever we want to calculate the c value, we equate the expression a plus b plus c with the first term in the original sequence. So this is very important. K plus k, whatever, guy. So these are important expressions to get a, to get b, to get c. To get the a value, we use the expression 2a, we equate it with the second constant difference. To get b, we take the expression 3a plus b, we equate it with the first term of the first difference. To get c, we take the expression a plus b plus c, and we equate that with the first term in the original sequence. So we're going to look at an example now. Right? Let's look at an example so that we can more fully understand how to use these expressions. 1, 2, 3. Example 1. The quadratic pattern 3, 11, 21, and 33 is given to us. Now we need to determine the general term, in other words, Tn. So we are given the quadratic pattern 3, 11, 21, 33, and the question says determine the general term. So how do we go about finding the general term? What we will do is we'll take this original sequence and we are going to find the first difference first and then the second difference. So let's go. To find the first difference, we say T2 minus T1. 11 minus 3. So what's 11 minus 3? In the comment section, you guys can help me out. 11 minus 3 is equal to 11 minus 3 is equal to, thank you, 8. You're not 4. Then we check 21 minus 11 is equal to, okay, definitely not 9. 10, yes. Then 33 minus 21 is equal to, so as you can see, guys, my first difference forms an arithmetic sequence or a linear sequence. And we know that a linear and an arithmetic sequence have what we call a constant difference. So now we are going to find the second difference, which we know should be constant, 10 minus 8, together with 12 minus 10. What does that give us as our answer? Minus 8 together with 12 minus 10. Yes, Grant, thank you. For once you're answering right. I think you were answering incorrectly on purpose, weren't you, in the beginning? Okay. Then what we do is we earmark the second constant difference, because remember, we want to determine the general term, in other words, the nth term. And in order to do that, remember the nth term, or Tn, of a quadratic sequence is given by Tn is equal to a. So we want this a value, an squared plus bn, we want this b value, plus c, we want that c value. To get the a, we take this expression 2a and we make it equal to the second constant difference. So let's do that. 2a is equal to, what's the second constant difference? It is 2. So we say 2a is equal to 2, and then we solve for a. So 2a is equal to 2. When you solve for a here, what do we get, guys? The a value is equal to, okay, indeed, Grant. Grant is granting there in the comment section. Okay, yes. Divide both sides by 2, we get a is equal to 1. Okay, that's the a value. We are done. To get a, we take 2a, we equate it with the second constant difference. Now we want to find b. To get b, we take the expression 3a plus b and we equate it. The next value that we need to take into consideration is the value 8. We equate it with 8. And remember, our a value we already got, which was 1. So we're going to say 3 times, in brackets, we substitute the value of 1, which was there. We then plus the b value is equal to 8, and then we solve the equation. We solve for b. So what will the b value be? 3 times 1 is 3 plus b is equal to 8. So what's the b value going to be, guys? From what you can see when you work it out, what do we get for b? Okay, we take the 3, we transpose it. The 3 was positive. When we transpose it, it becomes negative 3. And 8 minus 3, that gives you 5. Thought of in another way, what 3 plus what will give you 8? Think about it that way. 3 plus what will give you 8? It has to be 3 plus 5. So that's why B is equal to 5, if you think about it just a bit differently. Then our last expression that we are going to use in order to find C, the first term in the original sequence. A plus B plus C is equal to the first term in the original sequence. So we're going to write down the expression A plus B plus C is equal to 3. A, we know is 1. Substitute 1 in the place of A. B, we just got it. We know it's 5. Plus C is equal to 3. Then we solve for C. 5 plus 1 is 6. We take the 6 over, it becomes negative 6. So that means our C value is equal to, what's 3 minus 6, guys, in the comment section? 3 minus 6. Be careful. 3 minus 6. Yes. Mochiba. Negative 3. Can't be 3. Not positive. 3 minus 6 is negative 3. Then we conclude. Tn is equal to, now remember, in the place of this A, we are not going to write A, but we're going to write down the value that we got for A, which is 1. In the place of B, we're not going to write B, we are going to write the value that we got, which was 5. And in the place of this C, we are going to write negative 3. So the final nth term is going to be 1n squared plus 5n minus 3. This is the nth term of a what? Quadratic pattern. 3, 11, 21, and 33. As simple as that, guys. Okay, so that's how, guys, we find the general term, the nth term, Tn, of a quadratic pattern. Okay. Let's look at a follow-up question that can be asked based on the very question. The next question says, calculate the value of the 12th term, or asked differently, T12. If they ask us to calculate the value of the 12th term, or in other words, T12. So this here and that mean the same thing. 12th term or T12 just generally means the same thing. In other words, what do they want? They want me to take that equation that I had gotten. Okay, you have to remember, I had gotten this general term. Now they want me to calculate the value of the 12th term. Okay, so this 12th term has to do with the position. Okay, position number 12. We want the value of the term, the one that occupies the 12th position. That's what we want. So that means we are going to substitute in the place of n 12. And what we do, we substitute 12 in brackets everywhere where we see n. Okay. Yeah. We can grab our calculator. we get the value of the term. It's 201. Makes life easy. This is the value of the term. Okay. Straightforward, guys. Sound good enough? Move on to the next question. Calculate the value of the 12th term. So all you simply do, guys, is you substitute in the place of the n, because remember, the n means position. All right. So if they want us to calculate the value of the 12th term, it means in the place of n, we substitute 12. All right. And then we substitute 12 using brackets. Okay. And then we simply use our calculator and we go and substitute in the place 12 squared plus 5 times 12 minus 3. And then that gives us the answer just like that. Okay. The next question says, which term in the pattern is equal to 497? Which term in the pattern is equal to 497? Okay, slightly different question here, because this one was asking for the value of the term when we are given a specific position. This one is saying which term in the pattern is equal to 497. So here we are given the value of a term, and what we want now is the term number, or in other words, the position that this term value occupies. Right. So what we do is we equate the nth term with 497, the value of the term. Tn is obviously n squared plus 5n minus 3. So that means in the place of Tn, n squared plus 5n minus 3. On the left hand side, we have this equal to 497. Now when we are at this stage, we can then write the equation in standard form. We take the 497 over, we get negative 3 minus 497. That is n squared plus 5n. If you subtract these two constant terms, you get negative 500. Then what is your responsibility now? It is to solve for n. Two things you could do. You could factorize this equation, or you could use the quadratic formula. When you use the quadratic formula, you can use the subject n minus b plus minus. Okay. As you might find this may be a little bit easier to use. Okay. Maybe some of you may find it very hard to think of factors which when you multiply give you 500, but when you add give you 5. So to sort of like cut that long process, you could use the quadratic formula. Remember, your 1 is A. Your positive 5 represents the B value. And then your negative 500 represents C. So I'm going to say n is equal to, we know that the quadratic formula is usually x is equal to, but because our subject, our main subject in the equation is n, we use n because it is the main subject variable. So you are going to then write minus b follows, which is in brackets positive 5 plus minus b squared in brackets 5 squared minus 4. A is 1, C is negative 500 all over 2 times the A value is 1. Okay, A, B, C. A was 1, B was 5, and C was negative 500. So in the place of B, you can see what I substituted. In the place of A, you can see I substituted 1. And in the place of C, you can see I substituted negative 500. And then, of course, in the place of A in the denominator, I substituted 1. Then I can work it out. Just grab my calculator. Go to my fraction symbol. That then obviously makes that appear. Then at the top, I simply say minus brackets. I put the 5, I close. I put the plus. I put the square root. I put my 5 inside the square root and I square it. Minus the 4. I bracket 1. I bracket negative 500. I close it. Go downstairs. It's 2 times 1, which I know is 2. I say equal. I get the value of 20. Okay. Get the value of 20. So that means n is equal to 20, or take my calculator again, go back up, go and delete the positive sign, put in the negative sign, so I can find my second value, which is negative 25. Or n is equal to negative 25. Now guys, our n values, we have n that is 20, which is positive, and n which is negative 25, which is negative. But what would you say n stands for? It stands for a position. Okay, like you position 1, position 2, position 3, in term 1, term 2. So which one can I accept? Is it 20 or negative 25, or can I accept both? Can a position be negative? Perhaps. N cannot be negative, so it's 20. So we then say n cannot be. We put the cannot be sign, you see. So we scratch the equal sign so that n we know is not negative 25, and we know that n is equal to 20. Okay, so let's answer the question. We have answered. Let's move on to the next question. The next example that we can have here, if negative 2x, 8, 19, and y is a quadratic number pattern, determine the values of x and y. I repeat, if negative 2x, 8, 19, and y is a quadratic number pattern, determine the values of x and y. Negative 2, x, 8, 19, y is a quadratic number pattern. Determine values of x and y. So what do we do with this particular question? Well, we are told it is a quadratic number pattern. And we need to determine what? values of x and y. Sorry about that. Okay. So what's very nice about such questions, as I'm sure you saw last year, is we can first find the first difference of this particular pattern. So the first one, x minus 2. Remember, the difference between the two, this is already negative. So it's going to be x minus 2, which will give us x plus 2. Okay, do we understand why this is x plus 2 for the first difference of x and negative 2? Are we together there, guys? Can I move on to the next difference? X minus 2. This value is already negative. We are subtracting, of course, but we are subtracting negative 2. All right, so that's why the negative times the negative in between gives me a positive. So it's x plus 2. Look at this, 8 minus x. Look at this difference, 19 minus 8, which should be very clear what it is. It's 11, and then y minus 19. That's my first difference. Then I could find my constant difference, 8 minus x minus x plus 2. That's like saying 8 minus x minus, remember this is a binomial, so I'm going to put it in brackets so that 8 minus x, I take the negative x, I distribute it, negative x minus 2. Like terms give me negative 2x. 8 minus 2 is 6. So my expression here is negative 2x plus 6. Right, let me repeat that again. 8 minus x minus the entire 2 terms. So that means it's 8 minus x minus the entire 2 terms, means in brackets the x plus 2, distribute the negative, add the like terms. Okay, so hopefully you guys see why I get negative 2x, because the minus x gives me negative 2x. 8 minus 2 gives me 6. My expression here is negative 2x plus 6. Let's move on here. 19 minus 8, that should have given me 11. So I have 11 minus brackets 8 minus x. I distribute the negative, I get 11 minus 8 plus x. Then like terms, that gives me x. 11 minus 8 is positive 3. So I have x plus 3. Then lastly, y minus 19. Remember, this 19 minus 8 is 11. So I have y minus 19 minus 11. Okay, minus, because this 19 minus 8 is 11. That's positive. So as I say y minus 19 minus the 11, what does that give me? Y minus 30. So that means I have y minus 30 as my last term in that second difference. But guys, having gotten all of this, what do I know about my second difference? I know that the second difference is constant. So I see that, for instance, this expression and this expression both have x in it. So let's deal with these two. Because we know that the second difference is constant, I can take these two and equate them. Negative 2x plus 6 is equal to x plus 3. And let's solve for x for these two expressions. Why am I saying negative 2x is equal to x plus 3? It's because in a quadratic number pattern, the second difference we say is constant. So I can say negative 2x plus 6 is equal to x plus 3. Then let's solve. Negative 2x, take the x over, negative x. 3, take the 6 over, minus 6. Then what do I get? Negative 3x is equal to negative 3. And then the x value, divide both sides. I'm going to divide by negative 3 both sides, because this is the guiding division. This is negative 3, I divide by negative 3. What I do on the left, I do on the right. The answer is 1. So I have x. I've just calculated or determined the values of x. The last thing now I need to find is y. So I'm going to go there, back to this constant, second constant difference. I know this is y minus 30. Okay. Then I can maybe take this expression, make it equal to that one, or I could make that expression equal to that one. You decide. So let's just say y plus 30 is equal to x plus 3. Since I found what x is, in the place of x, I'm going to substitute 1. So we have y plus 30 is equal to 1 plus 3. How do we solve this? Y is equal to 1 plus 3 is 4. I take this positive 30, transpose it, becomes negative 30. So that means y then becomes equal to negative 26. Y is equal to negative 26. The value of x is 1. The value of y is negative 26. And all this because what did we apply as our constant? Once we find the first difference, and then we find the second difference, though the second difference has expressions, I'm going to use the concept of second difference being constant to make equal two expressions. So that's why I equated these two expressions, because I could see they are the ones that have x in them. All right, I find my x value, and then after getting my x value, I can then take another expression with y, equate it with the one that has x, and then obviously since I have 1 as a value, I can go and substitute it immediately in the place of x, and then solve for y. Okay. W is in the chat. Any questions about this question? Okay, guys, the minute one error gets made here, because x, maybe you just write x minus 2. Imagine if the expression is x minus 2, it throws everything off, right? So that's why your signs, your numbers, your variables, all the tricks in the trade need to be known and mastered by you. Okay, all right. Can we move on from the question, or is there questions? Motiba, Tamsin, any question, or are we good? Adele Vandarkai, or anyone? Anyone? Is there someone out there? Anyone? Anyone? No. Nicholas Cameron, when did you even join this live lessons and coming in and saying no immediately? Or you mean there's no questions? Or you mean you don't understand? Which one is it? Nicholas Cameron, Miss Motiva. Is the no for saying no questions, or is the no saying I don't understand? Which one is it? Yeah. Guys, just back to this quadratic number pattern we had gotten earlier on, n squared plus 5n minus 3. There is this a famous question that likes being asked as well, where they say, what is the minimum value? What is the minimum term of the sequence? What is the minimum term of the sequence? Very famous question, likes being asked a lot actually. You know, either they ask you the minimum or the maximum. The minimum or the maximum. What do we do whenever we are asked a question? They ask us what is the minimum or the maximum of the particular sequence, especially when we are dealing with quadratic. And I'm specifically referring, how do you deal with a question that asks you what's the minimum of your quadratic sequence? Any ideas? Minimum, sometimes they say, what is the smallest value? Because minimum would suggest that as well. Okay, thanks, Ria. You are sweet. We don't waste our time. We use the special formula. N is equal to minus p over 2a. That's it. Very good. Very good, Ria. Very good, Ria. We just use that formula. And with that formula, guys, we can conquer the world. Because we know Tn is equal to n squared plus bn minus 3. We know that b value is going to be 5. So we have minus into b, which is 5 over 2. A is the coefficient of n squared. So that's 1. So you would say n is equal to negative 5 over 2. Okay. So always take that into consideration. So there's specific questions where they ask that, and becomes important for you to note what it is to be done. So let me just give you one to do for me here, or let me say a few to do. Consider negative 145, negative 122, and negative 101. Okay. The first question that they're asking, and they're saying it's a QS, meaning it's a quadratic sequence. Negative 145, negative 122, and negative 101. 3 terms in the sequence. First question, write down the value of T4 for 1 mark. Second question, find the nth term. Hopefully you understand what they mean by the nth term. That's for 4 marks. 3, find the 76th term. Yeah, so you guys can answer these So blurry. So it's negative 145, negative 122, negative 101. And they're saying write down the value of T4 for 1 mark. Number 2, find the nth term for 4 marks. Find the 76th term. Which term is equal to negative 1937? Determine the maximum term in the sequence. Okay, I don't know why this view, it's bad, guys. Very, very bad. Doesn't matter what I do, it's bad. So I literally need to calm down to the screen so that you can see which term is equal to negative 1937. Determine the maximum term in the sequence. Find the 76th term. Find the nth term. Write down the value of term 4. Okay, so hopefully you guys have noted the questions. I will allow you some time to answer the questions. Are you guys winning in answering the questions? Okay. Yeah, here's another question as well. Between which two consecutive terms of the quadratic pattern will there be a difference of negative 121? Between which two consecutive terms of the quadratic pattern will there be a difference of negative 121? Okay, can you answer the question in chat? Number one, write down the value of T4. What did you guys get? What is the value of T4? Term 4. You know, and they're asking us to write it down for 1 mark. So there's no long calculations here. We just need to find negative 145 is the first term. Second term is negative 122. The third is negative 101. We need the fourth term. So what do we do when we want to get the value of the fourth term? Or what did you guys get? All right, negative 83. So how did you get it real? How were you able to get negative 83? Right, hopefully you're able to know about the first differences and see that there's a linear pattern or that is formed, you know. So for instance, negative 122 plus 145, because it's negative 122 minus minus. You have 23 here that is being added to get that. Then if you have that negative 101, you add it to 122, you get 21. So you can see what's happening from 23 to 21 to what? To 19, right? So what you're seeing here is that if you take this, you add it, you get that. Take this, you add it, you get that. Take this, you add that. And that's where we want to see. What's negative 101 plus the 19? Negative 101 plus the 19. That gives us negative 82. Yeah. So that is our answer. Negative 82. Okay, so let's see, let's know how to use our first difference, all right, to basically assist us in getting the next term. Because we take this term, you add it to that first difference, you get that. You take this, you add it to that, you get that. You take this, you add it to that, you get negative 82. So it's negative 82, guys. Right, Ria, careful. Next question, find the nth term. All right, what did you guys get as your final answer? Find the nth term. You know how to find the nth term. Take the second constant difference, you equate it with the second difference, which is constant, which by the way is negative 2. So 2a, you say it's equal to negative 2. So a is equal to negative 1. Hopefully you all got that. Then we say 3a plus b is equal to 23, because that is the value that is exactly in the position of 3a plus b. It's equal to 23. So 3 times 1 plus b. Okay, let's rewrite it. 3 times 1 plus b. 23. 3 times 1 is 3. You subtract it, so b is equal to 20. Okay, b is equal to 20. Okay, 3a plus b was equated to this 23. We substitute 1 in the place of a, because a we know is 1. 3 times 1 is 3 plus b is equal to 23. Take the 3 over, becomes negative 3. 23 minus 3 is 20. Then lastly, c, a plus b plus c is equal to negative 145. Substitute a, negative 1. Substitute b. Oh, error. Do you see the error that I made here? Sorry guys, my mistake. Negative 3. This was negative 1. 3 times negative 1. 3 times negative 1 gives us, sorry guys, my mistake. 3 times negative 1. That gives us negative 3. Then the negative 3 crosses over, it becomes plus 3. That gives you 26. My mistake. I nearly messed it up there. Okay. Then a, negative 1. B, 26. I want C. I've got that negative 145 the other side. Right. So that is C is equal to negative 145 minus 25. So that is C, that gives you negative 170. So Tn is equal to A, negative n squared, B plus 26n, C negative 170. This is my nth term. Okay, thank you so much guys. I nearly made a mistake there with omitting. You see, yeah, these errors that we make. We don't write -1, but we got -1. We write another number. So we must always verify and check that what we are writing down is correct. So that is the nth term. Find the 76th term. What do you guys get when you find the 76th term? Find the 76th term. T76. Okay, -3,970. Anybody else in the chat that agrees with that value? Or need we? -76 squared plus 26 into -6 minus 170 gives me 3,006. Okay, what is this? Which term? Determine the 76th. Where did I get the negative sign? I think I'm really tired now. Where did I get this negative sign? It's a creation. I created it. Let's just go change this. I was wondering what's happening here. Delete. Delete. What did I do now? You just said no, not -76 squared. 76 squared plus 26 into 76 minus 170. Okay, something's off here. Let me just redo this. 76 squared plus 26 7,042. That's what I get. So why did you get negative